Hello, hello. My name is Stacey Koprince. I am a GMAT instructor with Manhattan Prep, and I'm really excited for this first inaugural event that GMAT Club is putting on. Excited to be here and excited to talk about what we're going to talk about today. The GMAT is an infuriating test. It's a fun test, but it's an infuriating test too. And one of the things that drives people crazy is that we can't use a calculator and we can't use Excel to do math on this test. In that sense, it's very much not like the real world. The interesting thing is that the GMAT, the people who make the GMAT, they're not actually interested in seeing whether we are human calculators. They know in the real world that we're going to be able to use calculators or we're going to be able to use Excel to do math. What they're actually interested in is how we think about math, whether we have good, what's called number sense, or the ability to think or reason quantitatively. And so what this comes back to is, on the GMAT, there are many times when it seems like we have to do pretty annoying math to get to an answer. It turns out that there are a lot of different techniques and shortcuts that we can use to avoid doing tedious paper math if you're learning that way and if you're looking for those things. And so that's the theme of today's presentation is how can we avoid doing annoying math, how can we do math faster on the GMAT where we don't have access to a calculator or to Excel. So let's dive in and take a look. We're going to cover 5 principles today. Our first principle is don't do math until you have to. So see what's in front of you and see all of what's in front of you in a problem. And then make a conscious choice about how you want to work through that math and even in some cases whether you want to work through that math. There are times on the GMAT when something looks so annoying that I actually decide I'd rather not do it and I'd rather guess on this question and move on. Principle number 2, when I do have to do the math, I am definitely looking for easier ways to do it. And so we'll talk about some shortcuts today, and I'm going to encourage you to continue to look for additional shortcuts during your GMAT studies. Principle number 3, we're going to dive into a particular shortcut involving percents and something that we call benchmarking. Talk more about that in a little bit. Principle number 4 involves estimation. And principle number 5 involves knowing not just how to use fractions and decimals and percents, but when to use which form. So that's what we're about to learn. All right, let's dive right in. Take a look at, do you guys have, oh, I forgot, do you guys have paper and pencil? You need paper and pencil, or a pen. I'm going to make you do some math today. Grab it. All right, so here you go. Here's your first math problem. Go ahead.
Hi, Stacey. This is from GMAT Club. I don't think your screen is shared, so could you just quickly check?
Oh.
I'm going to stop you as a presenter for like a couple of seconds, and you can just switch the presentation.
Let me try. Are we good? Can you see it now?
Yeah, thanks.
Sorry about that. All right, guys, try this problem. Sorry about that. All right, I'm going to interrupt your math. What are you working on right now? What are you doing? I may have signaled this through my title, don't do math until you have to, but a lot of times what people will do is they'll see the 5/12 of 81, they'll start that, and then they'll be like, oh, that's annoying because I can't cancel anything, so now I need to multiply 5 times 81 and then divide by 12. What is that? Don't do that. Check out the entire math that you need to do first. When you're doing multiplication, it doesn't matter the order in which you do it. Multiplication and division can be done in any order. So lay out all of the math first and sit back for a second and examine. The 81's annoying with the rest of the math, but that 12 and that 240, there's an opportunity there. We can actually cancel out and simplify the math here. So now we've got 5 times 81 times 20. So okay, now I need to figure out what 5 times 81 is. No, wait, don't do that yet either. When you need to multiply a string of numbers or larger numbers, look for 5s and 2s first. So look to multiply 5s and 2s first, and think about why that is. 5s and 2s multiply to 10s, or to multiples of 10. And multiples of 10 are easier to work with. They're easier to multiply into numbers. So do that first. Oh, and now we just have to do 100 times 81, and that's pretty straightforward. So the math, if you do the math correctly in any order, you'll hopefully still get to 8100. The order in which, or the way in which you choose to do the math, can make a big difference in terms of how easy or hard, how fast or slow it is to get through the math. So first of all, just lay everything out and see what you've got. Always look to simplify before you multiply. And finally, when you do need to multiply, look for 2s and 5s. Try to pair those up first to get multiples of 10 to make the math easier. All right, that's our principle number 1. Principle number 2 is looking for these shortcuts. And we've already seen the first shortcut, multiply 2s and 5s first, so that we make the math easier. What if I hadn't had the 20 there? I had just given you 5 times 81. How would you multiply that? There are a couple of different ways that you can do this. I'm going to show you one particular way that will work anytime you need to multiply by 5. Anytime you need to multiply by 5. What you're going to do first is take the other number and cut it in half. So take 81 and cut it in half, and you get 40.5. Now, I just made the number smaller, but I was trying to multiply by 5. I should be getting a larger number to finish. So the next thing I'm going to do is take that decimal point, and I'm going to make the whole number bigger by moving the decimal place to the right. So 40.5 becomes 405. And that's it. That's the answer. 5 times 81 is 405. This will always work anytime you want to multiply by 5. It's a little shortcut. So go ahead and try that yourself with this problem. Now this problem I found a little bit more annoying than the last one, despite the fact that 37 is a smaller number than 81. And here's why. So my first step is to cut the other number in half, and I found it harder to cut 37 in half than I found it to cut 81 in half, for whatever reason, for my brain. And so what I did instead was, I said, okay, that's annoying. What's a close number that I find really easy to cut in half? And actually, it's a lot easier for me to cut 36 in half and get 18. And then I use that to move up to 37. If 36 divided by 2 is 18, then 37 divided by 2 has to be another 0.5 larger, or 18.5. And then I can go do my second step. Let's make this number bigger by moving the decimal one place to the right to get 185. And there we have it. That's the answer. All right. Let's just summarize where we are so far. Multiply 2s and 5s whenever you can to make the math easier. If math involves an annoying number, this is a general principle that you can use in broader contexts than the one that we just used. If it starts from an annoying number, try an easier number first. Try an easier way to do it first. And then get yourself to the annoying number from there, the way that we did with the 37 and 36. And then number 3 is, if I'm going to multiply by 5, I first want to cut the other number in half, but then make it bigger by moving the decimal one to the right. Now I have one more shortcut for you on this principle before we move on to our next one. Try this problem. All right, so this time we're dividing by 5 instead of multiplying by 5. But there's a process we can use for doing this as well. And in the same way that multiplication is sort of the opposite of division, we're going to do the opposite in the steps that we took to multiply by 5. So the first thing that you're going to do here is, instead of cutting the number in half, the other number in half, you're going to double the other number. So 81 is going to become 162. Now again on this one, I'm trying to divide by 5, which should make the answer smaller, but I just made it larger. So I still need to go back and make the number smaller again. And this time, I'm going to do that by moving the decimal one place to the left to get 16.2. And there you have it. That's it. Anytime I want to divide by 5, first I multiply by 2, and then I just move that decimal place one place over to the left. Done. So let's add that to our list of shortcuts for fast math. Now, this is just a little taste of shortcuts that you can do to do math more quickly on paper. There are all kinds of things like this out there. You can Google it. I actually learned some of these from a book called Fast Math Tips and Tricks, which I found years ago on Amazon and bought because I thought it looked interesting because, you know, I'm a math teacher and I'm a geek. But there's all kinds of these things out there, and you can also find more of them just by studying and looking at how to do things faster when you're doing GMAT problems. Start looking for these. Keep an eye out for these and make your life easier when you take the test. All right, let's take a look at principle number 3. Benchmarks. What are benchmarks? Tell me what 18% of 140 is, and you're not allowed to use your phone. Yeah, it's not so easy. That's really annoying. I can find 10%, I can find 20% very easily, but 18% is very annoying. So what can we do to use common percentages, or what we call benchmark percentages, to calculate something like 18% without too much trouble? So what we're going to do is we'll start from the 140, and our starting number is always considered 100%. So 140 is 100%. And then I go, okay, I need 18%. How can I get to 18%? Just thinking about percentages. Well, I can get to 20% by doing 10% twice. And if I want to go from 20% to 18%, I could subtract 2% to get to 18%. So how would that work out if I'm doing the actual math? Well, let's start by finding 10% of our starting number, 140. So that's 14. But I actually want 20%, right? So double that. That gives me 28. Now I want 2%. Oh, I can actually find 2% easily by just moving the decimal place 1 over on my 20%. All right, so that's 2.8. And then finally, take a look at this math over here. I want to do 20% minus 2%. So I'm going to do the same thing with the math over here. 28 minus 2.8, and there's my answer. So the cool thing with these benchmarks is we can lay out pretty much any annoying number that we're asked to calculate by starting from 100% and then using some combination of the benchmarks 50%, 10%, 5%, and 1% to get to whatever number we were asked to do. And then we're just going to add and subtract to get whatever the answer is at the end, the way we did right over here. So benchmarks are awesome. You can wow your friends at dinner this weekend by calculating 18% of the tip. Exactly. And they'll be like, wait, how did you do that? If you just get used to, again, using these benchmarks of 50%, 10%, 5%, and 1%. All right. Let's go take a look at our 4th principle. I call this estimate and not just when they tell you to, because on some questions, they obviously tell you that you can estimate. They ask you for an approximate answer or something like that. And certainly when they tell you that you're permitted to estimate, you want to go ahead and do so, right? It's easier to estimate than to do the exact math. But there are times that we can estimate even when they don't tell us. If you think about it on the GMAT, the answer to a math question is never a specific number, even on problem solving. The answer to a GMAT math question ultimately is just A, B, C, D, or E. It doesn't matter how you get there. So if you can estimate and save yourself some time and effort, then that will keep you fresher for the rest of the test. So important. So I'm about to pop up some mixes of answer choices for problem-solving questions, different examples. What I want you to do is just look at these and see whether, based only on the answers and the mix of answers that I give you, see whether you can brainstorm ways you might be able to estimate. All right, so just take a look. All right, did you spot anything with any of these? Actually, each one of these has some opportunities here. Now, estimation won't always get you down to a single correct answer, although sometimes it will. But sometimes that's a better path. It's better to get yourself down to 2 answers quickly and then guess and move on than to spend 3 or 4 minutes on a question and maybe not even get it right anyway, and also get very frustrated and have that affect your performance for the rest of the section. So the first set of answers that we have over here, the answers are what we call spread out. They're pretty far apart, each one. And so depending on the details of the problem, it might be enough to estimate either from the beginning of the problem or maybe partway through the problem in order to get to the answers. Certainly at the very least, when you see answers that are this spread out, you'd like to keep an eye on them as you're working your way through the problem, because you may discover when you're still a couple of steps from the end of the problem that you are actually close enough to tell, oh, it's got to be B, so I'm done. All right, next, take a look at that middle column. Here, maybe I can estimate that it needs to be greater than 0, or it needs to be less than 0, or something like that. We call this a crossover pairing of answer choices. They're crossing over some characteristic, and since they cross over this characteristic, we may be able to just go ahead and estimate. Another example of this one would be something like on a probability question. Some of the answer choices might be less than half, and some of the answer choices might be greater than half. And so when that's there, maybe I don't know exactly how to do the whole problem, but if I do know how to roughly estimate that it should be more likely to happen or less likely to happen, then I can narrow down some of the answers based on whether they're greater than 1/2 or less than 1/2. And then that final pairing looks a lot like the first one, but I changed answers C and E. So I made B and C closer together, and I made D and E closer together. If I get the mix, the full range that I get an answer, in the first column, the 3 through 113, I may very well be able to estimate myself down to a single answer. In the third column, I may not be able to get down to a single answer, but look at how the answers are clustered together. They're clumped together there. And so maybe I can get myself to, it's either 18 or 22. And again, I might decide that that's good enough on certain questions on the test. I have one more for you. This one's a little more complicated. So I'm going to put up another column of answers. And I'm actually going to give you some information this time about the problem. But I'm not going to give you the whole problem. Just take a look at the information that I give you and see if you can come up with any ideas about how you might be able to estimate in the answer choices to narrow down. Go for it. Any ideas on this one? The answer choices alone don't meet the criteria, or don't appear to meet the criteria that I was talking about earlier. They're certainly not spread out. You could consider them clumped, but they're all clumped pretty closely together. So what are we going to do here? Well, so J and K are 20 miles apart, and they're walking towards each other. Now, I haven't told you anything about how fast these guys are walking, so you clearly can't actually calculate the answer here. But you can figure something out. If they're starting 20 miles apart, and then they're walking towards each other and they meet somewhere, that means that together they have crossed a total of 20 miles. J has walked some portion of that, and K has walked some portion of that. And one of the things that you can ask yourself is, well, which one did more of the walking? Which one walked more than half of the distance, and which one walked less than half of the distance? In a real problem, I would have had to give you some information about the speeds at which they were walking. And so possibly you'd be able to figure that out. Now, if you can figure that out, the awesome thing is that you can actually cross off 2 or 3 answer choices. If J walked more than half of the distance, then the answer is D or E. Or if J walked less than half, then the answer is A, B, or C. And we can even go a little bit further than that. Now I'm going to give something away, which is that J did less of the walking, so the answer is either A, B, or C. If you had to guess right now between A, B, and C, which one would you guess? Or my real question is, which one would you not guess? So these answers are clumped in a certain way. They're just not clumped by being close together the way they were in the third column of answers. These answers are clumped by adding to 20. C and D, 9 and 11, add to 20. And then B and E, 8 and 12, add to 20. So what's the significance of that? Well, look back at the problem. They're asking us how far J has gone. What do you think is a common mistake that a decent percentage of people would make on a problem like this one? Probably the most common mistake would be to accidentally solve for K instead of J. And so the test writers are going to put that answer in the answer choices, because if you're not paying that much attention, they don't want you to know that you made a mistake. They want you to think that, oh, you got it, and go pick it and move on. And so let's say 9 is the correct answer, then 11 is in there as a trap answer. Or let's say that 8 is the correct answer, then 12 is in there as a trap answer. 7 doesn't have the trap. 13 isn't in the answer choices. And so if you're guessing between 7, 8, and 9, don't guess 7, because it doesn't include a trap where you would expect to see a trap. We call these pair traps or paired answers, by the way. 8 and 12 are a pair, and 9 and 11 are a pair. And since there are 5 answer choices, there's going to be an odd one out. So 7 is the odd one out. Don't guess that one. It's probably not the correct answer. All right, so just back to this idea of even when a problem doesn't explicitly tell you that you can estimate, there are often things that you can do. Sometimes those estimations will actually still get you down to a single correct answer. Sometimes they'll just let you narrow down. But as we were talking about at the beginning, that can sometimes be useful and appropriate on a test like this one, where we can't possibly answer all of the questions. Okay, let's take a look at our very last principle here, number 5. Fractions, decimals, and percents. When you study these topics, they are always taught together, because you can take any single number and you can represent it as a fraction or as a decimal or as a percentage. They're all really the same number in the end. The key is that certain kinds of calculations are easier to do when the numbers are in a certain form, in a fraction form or a decimal form or percent form. And so one of the things that you want to study, since you do have to do this stuff on paper, is when is it easier to use a particular form so that I can make my life easier when I'm doing this math. So here's a little problem. Go ahead and try this. All right, that's about 45 seconds. I'm going to cut you off here. If you do this problem in the way that the problem implies that it should be done, you're going to take longer than you need to answer this question. One general theme for the GMAT is that they are going to give you problems that are, the implied setup is the more annoying way to do the problem. Because they're looking to see, again, they want to see your business skills and your decision-making and thinking skills. Can you look at the big picture and decide, you know, that's not the best way to do it. Let me change this up a little bit and do this differently to make my life easier. They're really looking for that. So a fifth, a quarter, and a half. Oh, and by the way, I have to give a shout out. So Payman, Rishi, and Sharmata are 3 students in one of my classes right now. So hi guys, thanks for being in my problem. So all right, so they're eating all the chocolates. They're not leaving very many for me. I'm a little annoyed. So how do I figure out how much is left for me? Well, I can add up the fractions that they're eating. But I'm kind of annoyed by that, you guys. I don't want to add fractions. I have to find common denominators to add fractions, and that's annoying. I'm not interested in doing annoying math to get through the GMAT, so what can I do instead? Well, anytime you see fractions, decimals, or percents, one of the things you want to think about is whether a different form of these fractions, in this case, would be easier to do the problem. And in this case, the answer is definitely yes. When I want to add, it's easier to use either decimal or percentage form. I'm going to translate these into percentage form because I personally like percentages better than decimals. But if you like decimals better, you can use that too. So a fifth translates to 20%. A quarter to 25%, and a half to 50%. And here's something else. I know these conversions because I've memorized them. There are certain common conversions that you want to make sure you know or have memorized for the test. So if you don't already have these memorized, add that to your to-do list. If you're working from our books, our Fractions, Decimals, and Percent Strategy Guide, there's actually a table in there that has a list of the common conversions that we recommend that you memorize. Okay, so what have I got here? So they ate 95% of the chocolates. You guys ate them all. All right, so they leave 5% of the chocolates for me. You might even notice, by the way, as you're adding these up, you might be thinking, wait a second, I know that 25 and 25 and 50 would add up to 100. So really, I'm just missing 5%. So you might get yourself straight to the 5% without even having to add to 95. Now, we're not quite done because the question didn't ask what percentage of the chocolates are left over. It did ask what fraction of the chocolates are left over. I have a percentage right now, so now I have to convert back. But you know what? I'm willing to do that conversion because I don't want to add fractions. It's too annoying. 5%, by the way, is also on the standard conversion list to memorize. So if you've got it memorized, you already know what it is. If not, here's a little math you can do to get there. Just take that 5% and translate it into 5 over 100, and then simplify down to get 1 over 20. And that's the answer. They only left me a 20th of the chocolates. All right, so for these guys, typically, for fractions, decimals, and percents, typically it's easier to add or subtract in either percent or decimal form. On the other hand, if you're multiplying or dividing, it's often easier to use fractions because you can simplify, you can cancel stuff out and make the math easier. And by the way, I want to pull us back to the estimation piece. You could potentially estimate on some of these at some point as well. So you'd want to be thinking about that as you work your way through the problem. And just finally on this one, do memorize the common equivalents. As I said, if you're working from our materials, you can look at in our fractions, decimals, and percents guide to see what we recommend that you memorize. In general, you want to memorize quarters, fifths, thirds, eighths, and then a few not quite common ones like 5%, 1%, something like that. A few of those. All right. We did it. You guys made it through. We have the 5 principles. Let's just review here. Please don't do math until you have to on the GMAT. Make your life easy. Set it all up. Take a look at it. Decide whether you want to do it in the first place. And you should actually sometimes be deciding that something looks way too annoying to do and you don't want to spend the time and effort to do it. If you are going to do it, take a look at the whole thing and figure out where you can find some shortcuts, where you can do the math in a different order or set things up or use a little shortcut that you've memorized to make it easier to do whatever it is that you're looking at. Specifically, some ideas. When you're working with percents, try to use the benchmarks of 50%, 10%, 5%, and 1%. Please look for opportunities to estimate. Don't just do that when they tell you you can. Start to get a sense on questions for when you can and can't estimate and how aggressively you can estimate. One of the things I ask myself when I'm done doing practice problems is just going back over it and saying, hey, was there an opportunity to estimate here somewhere that I missed? Could I have made my life easier answering this question? And then finally, have a good sense before you get into the test for when you would want to do certain kinds of math operations in fraction form versus decimal or percent form. Again, make your life easy when you take this test. All right, I have a cool thing for you. So GMAT Club is very generously offering a free subscription to their tests. And all you have to do to win this is to comment down below. That's it. All you have to do. And GMAT Club is going to announce a winner sometime next week. And speaking of GMAT Club, I would like to thank them for putting on this event today. It's fantastic. I hope that they continue to do more of these sessions, and I'm very honored to be here to help you guys with some fast math tips and tricks. Thank you for taking the time to come and listen to me, and good luck with your GMAT studies.